Our warm-up today is going to be practicing product, quotient, and chain rules using functions. And I have three functions here. I have f of x equals x cubed g of x. I have h of x equals g of x divided by 3x. And I have g of x at the bottom equals f of tangent of x. And I want to get the first derivatives of all three and the second derivative of the first one. If you pause it, you can make an attempt on the video. Otherwise, I'm going to start working through immediately. We should recognize the first one as f times g. So f prime g plus g prime of x. It is the product rule. With that said, we know the derivative of x cubed is 3x squared. We also know the derivative of g of x is g prime of x. So with that said, I'll pull this out and we'll window in a little bit. So, using the product rule, derivative of x cubed is 3x squared, and we just have g of x. Then we have to take plus the derivative of g of x is g prime, and then just x cubed. That is the product rule. Now, to take the second derivative of this situation, we have to recognize f times g of x. That's product rule once. And then when you have the plus over here, I'll do it in blue, we have f and g prime of x. And that makes the product rule here again. I did not combine like terms in the last one, but you'll notice that 3x squared times g prime of x is repeated there twice in the middle. So you could have written 6x squared times g prime of x. But again, this is the product rule. We should be able to step through this with some practice. Again, looking at the derivative of 3x squared, we get 6x. Derivative of g times g of x. Then we have 3x squared, the original, times g prime. On the other side, we had x cubed, which is derivative of 3x squared times g prime. And then x cubed times derivative of g prime is g prime prime. Moving on to h of x, we have g of x divided by 3x. That is a quotient rule, where we take the top, derivative of the top times bottom, g prime times 3x, minus top g of x times derivative of the bottom, which is 3, over the bottom squared, 9x squared. Then finally, the last one, we have f of tangent of x. This is a chain rule. We know the derivative of f of tangent x is f prime tan x, but then we have to take the derivative of the inside. We know the derivative of tan x is secant squared x. Three derivatives, product, quotient, and chain rule, all use the functions. Something we have to be able to do as we move forward. Also, I'm going to couple to this problem. Find the equation of the tangent to the curve at x equals 1 of the function f of x equals x minus 1 over x cubed minus 2. So what this is really asking for is find the equation of the tangent line at x equals 1 and y equals whatever. So I got to find the derivative. I got to use the quotient rule. And you memorize the quotient rule was f prime of g minus g prime of f all over g squared. I want to take the derivative of it. So when I look at the function f of x, x minus 1 is the numerator, that is f. X cubed minus 2 is g. So we'll do the quotient rule along with power rule, because they're all simply powers. The derivative of x minus 1 is 1 times x cubed minus 2 minus x minus 1 from the top. The derivative of the bottom is 3x squared. That is all over x cubed minus 2 quantity squared. I will not simplify since I'm looking for the tangent line. And I only need to have the x value. So I will plug in x is 1. And when I plug in x is 1, I get 1 minus 2 minus 0 on top, all over 1 minus 2 squared on the bottom, which is negative 1. I now know the slope of the line at x equals 1. The slope of the line is negative 1. That's the slope of the tangent line. Big deal. Now all I need is a point. I know the x value is 1. I plug 1 into the original function up here. I can get that the y value is 0. So now I have a slope and a point, and it is easy. The point is 1, 0. The slope is negative 1. Use point slope form. And that is the slope, that is the tangent line at x equals 1 of the function x minus 1 divided by x cubed minus 2. Again, keep practicing. You should be masters at these type of things here by chapter 5.